Hello, let us see the concept of threaded binary tree, and this concept is taken from the two book. One is written by Simon Lipsus, another one is the Horowitz Shahani book. Now, what is threaded binary tree, or let us understand what are the problems of binary tree that are overcome by threaded binary tree. So, let us draw a binary tree, and we assume the binary tree is implemented using doubly linked list. So, consider a binary tree which has 10 as its root node, 70 as its left child, 30 as its right child of 70, and 90 as the right child of 10, and 90 has 50 as its right child, and 50 has 60 as its left child, and 50 has another 50 has a right child, um, 65. So this is a binary tree which is implemented using doubly linked list. Now in this binary tree, how many nodes are there? That is how many. So the nodes are represented by n. So how many nodes are there? 1 2 3 4 5 6 7 nodes are there. Now how many links are there? That is the number of links, or it is also called the number of edges in case of graph theory. Now as this is a tree, we know that a tree with n nodes has n minus 1 links or addresses. So the number of links or the number of edges is exactly n minus 1. So here is 6. So 1 2 3 4 5 6. So there are 6 edges. Now you can see that a node, this is a node, and this is a special node called root node. Now we can see that a node contains three parts. One part is called the data part, another two part is called the address part, or this is called the left address part or right address part. So this is called the left address part and this is called the right address part. Now if we see the content of the address, consider the first root node. As the root node contains the left subtree or left child, the left link contains not null values. This left link contains the address of this node. So this content is not null. Similarly, this content is not null. Now as 70 contains a right child, the right link or the content of right address part is not null. But as 70 does not contains any left child, the content of the left address part of 70 is null. So this is null. Similarly, as this is a leaf node does not contains any node, so it's both left link or left address part and right address part is null. Similarly, for this node, as it does not contains any left child, so its left link is null. Now 60, as it is a leaf node, both of its left and right address part would contain null, and this is true for this leaf node also. So we can see the address part contains either null value or not null value. Now how many not null values are there in this tree? So number of not null value is equals to the number of links. So the number of, this is the number of non null values. So this, any binary tree with n node contains n minus 1 non null values or n minus 1 edges or n minus 1 links. As each node contains two addresses or two address part, the total number of address part in a binary tree will be n. So total number of address part in a binary tree will be 2n. So in this particular example, how many address part are there? There are 2 into 7, that is 14 address part are there. But among this 14 address part or among this 2n address part, there are two different types of address. One is the null address another one is the non-null address. Now we can say that total number of address is same as total number of non-null address plus total number of null address. Now from this equation we can say that the total number of null address is equals to total number of address. So total number of address is 2n, we obtain this from here, and total number of non-null address we obtain from here. So this is n minus 1. So total number of null address will be total number of address minus total number of non-null address. So this will be n plus 1. So as in this case there are 7 nodes, total number of null address in this situation will be 7 plus 1, that is 8. So we can see that this particular tree has 8 null address: 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 null address. So the important thing is that given a tree with n nodes and we assume the tree to be binary. So given a binary tree with n node, we can say it has n minus 1 non-null address, or we can say n minus 1 links or edges, and it has exactly n plus 1 null addresses. Thank you.